it's important to understand the relationship between the sides and the angles of similar figures. So because corresponding sides of similar figures are what? What were we talking about yesterday? When we talked about the beginning of the unit with dilations, the sides are what? Start with a P. Proportional. Yeah. Corresponding sides of similar figures are proportional. So, when you're trying to set up a problem to find the missing side of two similar figures, you would set up a proportion. So when you're trying to find a side and you're given similar figures, you set up a proportion to solve because their sides are proportional. Because the corresponding angles of similar figures are blank, what do we know of the angles of similar figures? They're the same. And what is another word for the same in geometry? Congruent. Because the corresponding angles of similar figures are congruent, well, what would we do to solve that problem? We would set them what to each other? Equal to each other. So when you're finding sides, set up a proportion. When you're finding angles, set them equal. When you're dealing with similar figures. So take a look at this first example. It says in the diagram below, triangle DFE is similar to triangle ACB. Find the missing sides in each triangle. Okay? This is where marking your angles is really, really important because it helps you decide which sides match up with which. So if we have DEF, I'm going to put one arc at D, DFE, 2 arcs at F, and 3 arcs at E. I'm going to go in order. I'm going to follow that same pattern in the other triangle. 1 at A, 2 at C, 3 at B. And we're trying to find the missing side of each triangle. Well, a variable is not written there, so I'm just going to put one. I'm going to make this one X. I'm going to make that one Y. 2 different sides, we're going to have 2 different variables. And we're trying to find missing sides, so what are we going to set up? Okay. What did we just say? For finding missing sides, we set up a proportion. And a proportion is just when you have a fraction equaling a fraction. So that's what we're going to set up. Which variable do we want to solve for first? Do we want to solve for x or do we want to solve for y? For y, we're going to solve for y first. Doesn't really matter in this case. We're going to solve for y. I'm solving for y first, so I'm putting y in the top. Okay. Well, which side matches up with y in the other triangle? Y is in between 3 arcs and 2 arcs. Which side is also in between 3 arcs and 2 arcs? 8. So 8's going to go in the bottom. Here's the thing. Is it going to help us if we have another variable in this problem? It's going to help if we make x one of our other fractions? No, right? Because we can't have more than one type of variable in a problem. You can only have one type of variable in a problem. So picking a side that has x in it isn't going to work. So the fraction that you have to pick has to have 2 numbers. Okay? We put y in the top. So the number that's going in the top of the second fraction has to be the same exact triangle as y. Which side do we have to pick? In the bottom triangle. 14, right? Because 14, what does 14 match up with the other triangle? 7. So we make a fraction that with numbers. If we pick 20, which side does 20 match up with in the other triangle? X. So then we would have 20 over x, and then we have more than one type of variable in the problem, and then that we can't go anywhere with that. But we can pick 14 and 7. That makes y the only variable. And again, y is in the top, so 14 has to go in the top. You have to stay consistent. 8's in the bottom, so 7's going to go in the bottom. Think back to the very beginning of the year. How little trick we use called cross multiply. So there's multiply across. So we multiply across. Y times 7 is what? 7y. And 8 times 14 is 112. And then what do we have to do with the 7? Y. And then 112 divided by 7 is what? 16. There we go. Well, now we have to find x. And the process is very, very similar for x. And what I like to do, I already set up a problem with numbers. I steal the one that has the numbers and use it to set up my other one. It's less work when I do it that way. So I'm still going to use 14 over 7. And that's still going to be equal to a fraction. But this time around, we're finding x. Where does x have to go in that second fraction? The bottom. Very good. Why does it have to go in the bottom? Yeah, because x is in this top triangle. Well, look at your fraction. Is 14 or 7 a side in the top triangle? 7. So x has to go in the same spot as 7. Right? You have to stay consistent. Okay? So which side in the other triangle does x match up with? 20. Okay? 14 and 20 are in the same triangle. They're in the same spot. X and 7 are in the same triangle. They're in the same spot. They're both in the bottom. And then we use that same process to solve. We just cross multiply. Multiply across, multiply across. 14 times x is just 14x. What's 7 times 20? 140. And then what do we have to do with the 14? Divide. And we do that. 140 divided by 14 is... Some of you might be thinking, well, isn't it kind of obvious if 14 over 7 simplifies down to 2 and those fractions are equal, so then what, doesn't y have to be 16? Yeah, sometimes it's really easy to look at that and tell. But sometimes our answers are decimals, and you can't tell them easily. So it's good just to practice the process, because you have to do this when it's a decimal. Okay. Questions over that? In example 2, it says in the diagram below, triangle ABC is similar to triangle, it should be DEC. Thought I caught that. Find the value of x. So again, it's really helpful. Mark your angles. It tells you which side matches up with which. So A, B, C. 1 arc, 2 arc, 3 arc. They're going to follow the same pattern. D, E, or C. Are we trying to find a missing side or a missing angle? Yeah, we're dealing with sides, right? So what are we going to set up to solve when we're dealing with sides? A proportion. So a fraction equals a fraction. We're trying to find x, so I'm going to put that in the top. Then I have to figure out which side matches up with x. What side matches up with x in the other triangle? And if it's helpful, we kind of have triangles sitting on top of one another. We have this yellow triangle in the bottom and this purple triangle in the top. Okay. So x is in this bottom yellow triangle, and it's in between 1 arc and 3 arcs. So which side matches up with x in the top triangle? Which side is in between 1 arc and 3 arcs? 6. So 6 is going to go on the bottom of that fraction. X is in between 1 and 3. 6 is in between 1 and 3. So they match up. We have to stay consistent. X is in the top, and it's in the yellow triangle. So then we're going to pick a side in the yellow triangle. And this one's nice. It doesn't really matter which side you pick. Which side do you want to pick in that yellow triangle? 8 or 12.8? 8. I like 8 too, because it's not decimal. Easy to work with. So I have to put 8 in the top. X is in the top. 8 has to go in the top. is equal to which side in the other triangle matches up with 8? 5. 8's in between 2 and 3. 5's in between 2 and 3. And then cross multiply. When we cross multiply, x times 5 is 5x. 6 times 8 is what? 48. What do we have to do with that 5? 5. And 48 divided by 5 is what? You're looking 5 right here. What do we get when we do 48 divided by 5? Good. 9.6. And sometimes your answer is a decimal. Okay? Sometimes though, if you get really weird decimals, like really long, repeating ones, that much of a pattern, that might indicate that you set your proportion up wrong. Sometimes that is the answer and you need around. So that's a good indicator to go back and make sure you set up your proportion and you are consistent. Okay? And then check here how you cross multiply. And if you do all those things and you're like, I think this is the answer because I did not mess anything up, then you have a weird decimal answer. Okay? But sometimes that's a good indicator that you set your proportion up incorrectly. But sometimes we do get weird decimals, so just check. Questions over there? If we take a look at example 3, it says in the diagram below, again, mark your angles. Triangle DEF. So 1, 2, 3. It's similar, that squiggle means similar. CBA. So 1, 2, 3. This is why it's super important to mark your angles. If you don't mark your angles, you're going to match up the wrong side with the wrong side just because of how it's oriented. Okay? You have to mark your angles. They're meant to be disoriented, so to make sure you mark your angles. Okay? And we're trying to find the value of x. Is x a side or an angle? It's a side. So what are we going to set up to solve? Yeah, the fractions. A fraction equaling a fraction, a proportion. We're trying to find x. I'm going to put that in the top. Which side matches up with x if it's in between one arc and 2 arcs? It's in between one arc and 2 arcs. Which side matches up with x? Very careful. This is tricky. 30. That's why we have to mark our angles. If you didn't mark your angles, it looks like x matches up with 21 because they're both flat and they're both that's what they're sitting on. But you can turn these triangles around and orient them in the same way. So that's why you have to pay attention to how those, you have to mark your angles. Okay? Hold on. I put 3 on too many, sorry.
That's why I was like, wait.
That's why you were confused. Yeah, E gets 2. Sorry. I get 2. I'll slide into my arcs. Okay. So x is in between 1 and 2. 30 is in between 1 and 2. They match up. Okay? That's why you have to mark your angles. Then the next one, it's great when they only give you 2 sides in each triangle because how does the other ratio have to be set up? We already used this one. How do we have to set up the next one? What has to go on the top of the other triangle? Or the fraction. Okay? Good, 77. They're in the same triangle, they're in the same spot. So then what has to go on the bottom? 21. Okay. What method do we have to use to solve this? Cross multiply. When we have this binomial on the top, remember when we cross multiply, it's really, really important to put parentheses around it. Helps you organize your work. Okay. So make sure when you have a binomial, put parentheses around it, and then cross multiply. The reason why we do that is because when we cross multiply, we're multiplying this entire thing, 11x plus 11, by 21. And that's equal to, what's 30 times 77? 2031. Good. And then when we solve, what do we have to do with that 21? Distribute it. So we distribute that 21. It's nice because it's all 11. What's 21 times 11? 231. Plus 231. And then we just solve it like a normal equation. So this 231 we're adding, how do we move it over? Subtract it. Cancels. 231x is equal to, what's 2,310 minus 231? 2079. And then our very last step, what do we have to do with that other 231? Divide. And when we divide, x ends up equaling what? And we're done. Questions over that? You have to stay consistent. You have to mark your angles to make sure the right side matches up with the right side. Okay? If you don't mark your angles, they're meant to be disoriented to try to set you up in front. You have to mark your angles. You cannot tell without marking. Okay? You have to mark. Questions over that? Okay. Two more. We take a look at example 4. It says in the diagram below, triangle MNQ, so I'm going to mark my angles, MNQ, is similar to triangle M, this guy right here, again, O, and we want to find the value of x and y, so finding two variables. These triangles are a little different because they're stacked on one another. We highlight, we have this triangle, this tiny triangle stacked on top of this big triangle. There you go. So how we set things up are a teensy bit different when you have these stacked triangles. For the purpose of this problem, at the end of the day, it doesn't matter which one you solve for first, x or y, but to help us figure out how to solve for x, we're going to solve for y first. Okay? And is y a side or an angle? It's a side. So what are we going to set up to solve? A proportion. So we have a fraction equals a fraction. And we're solving for y. Y is in between 2 arcs and 3 arcs of the big purple triangle. So which side in this yellow triangle matches up with y? 7. Okay, so it's going to be y over 7 is equal to, which side do we have to pick in the big purple triangle? Do we have to pick OM or PM? There's one we have to pick. Why do we have to pick OM? Yeah, the other side has an x in it. We can't have more than one type of variable or we're not going to get anywhere when solving. We have to pick OM because there's no x's. Okay? And this piece is 4 and that piece is 8. What's the total distance of OM? If from here to here is 8. And from N to O is 4. What's the total distance of that whole side? It's 12, right? That whole side is 12. So we're going to put 12 in the top of the other fraction because, again, y was in the purple triangle, it's in the top. So a side of the purple triangle has to go in the top. When you have these stacked triangles, to get the lengths of the big side of the sides of the big triangle, you have to add those pieces together. So then which side in the little yellow triangle matches up with 12? 8. Then 12 is in between 2 and 1. 8 is in between 2 and 1. And they're kind of sitting on 8 was a part of it, so that makes sense to match up with 8. And again, how do we solve proportions? Let's multiply. 8 times y is just 8y. 7 times 12 is what? 84. And then what do we have to do with that 8? Divide. And 84 divided by 8 is what? 10.5? There we go. Question over that. If we take a look to find x, again, I like to steal a fraction I already set up when I'm doing two proportions in one problem. So I'm going to use 12 over 8. Makes my life easier, so let's see if I have to do it, but just steal that fraction. Now we want to find x. Is x in the big purple triangle or is x in the little yellow triangle? The big purple triangle. So is x going to go on the top or the bottom? Top. Has to go with 12 was in the big purple triangle, so x has to go in the top. Okay. Well, here's the thing. X is represented from here to here. That's x. That's not really a triangle side. It's part of a side, but it's not an entire side. So just like here, how we added these two pieces together, we added 8 and 12, or sorry, 8 and 4 to get the entire side 12. We have to do the same thing with x and 10. When we add x and 10 together, what do we get? X plus 10. So that's what's going to go on the top of that other triangle. So when you have these stacked triangles, you have to do that. So then which side in the yellow triangle matches up with x plus 10? Wait, which side? 12. No, not 12. Sorry, 10. Because 12 is in the big triangle. We want to look for the side in the little triangle. So x plus 10 is making up the big side. 10 is this corresponding side in the other triangle. Because x plus 10 is in between 1 and 3. 10 is in between 1 and 3. So what's really important? What do we need to write around x plus 10? We have to cross multiply. We have a binomial. What do we need to write around this? Parentheses. Helps organize your work. And then we just cross multiply. When we do so, what's 12 times 10? 120. And again, we're taking 8, and we're multiplying this entire parenthesis by 8. And then we solve. What do we have to do with that 8 when we solve? Distribute it. So we just distribute our 8. So we get 120 is equal to 8x plus 80. Move the 80 over. We get 40 is equal to 8x. And then what do we have to do with that 8? Divide. Good. When we do so, very good. X equals 5. Questions over that? I think stacked triangles are the trickiest because you have to remember to get the length of the big side, you're going to add these pieces together. So I think questions over that? One more. It says in the diagram below, figure ABCD is similar to figure EFGH. So I'm going to mark my angles. A, B, C, D, oh, that gets 4, is similar to E, F, I know there's 2, 3 on that one, F, G, and H. And it's saying that angle 70 degrees, so I'm going to mark it. And it's saying that angle G is 8x minus 18. Well, in this problem, are we finding sides or are we dealing with angles? Are we dealing with sides or are we dealing with angles? Angles. And what do we know about angles? What did we say? Set them equal. Very good. When we're dealing similar figures and angles, set them equal because they're the same. And then we solve our equation. So sides set up a proportion. Angles set them equal. You can't set up proportions with angles because they're not proportional. So it won't work out. Right? And then you just solve. Move the 18 over. You get 88 is equal to 8x. And then what do you have to do with the 8? Divide. So x ends up equaling what? 11. So the sides set up a proportion, angles set them equal when you're dealing with similar figures. Sometimes you just get in the zone of setting up proportions, and then we get an angle problem. We still try to set up a proportion. Just make sure you pay attention to that. Questions? Last one. And we have a word problem. Don't panic when you see a word problem when we're dealing with similar figures, because you're always going to have a diagram. So it's really no different than what we've been doing. There's just a really long paragraph that gives you information. But you will have a diagram. And sometimes you have to read the sentences to fill in your diagram, or sometimes the information is already written for you. Okay? But you'll always have a diagram when you have these problems. It's really no different than what we've been doing. Okay? Says Michelle wanted to measure the height of her school's flagpole. She placed a mirror on the ground 48 feet from the flagpole. So here's the mirror. Okay? And then she walked backwards until she was able to see the top of the pole in the mirror. Her eyes are 5 feet above the ground, and she's 12 feet from the mirror. Using similar triangles, find the height of the flagpole to the nearest hundredth of a foot. And we do not round correctly for here, I just realized that. Okay, so if you notice, it says using similar triangles. And I notice I have a triangle here, and I have a triangle here. Those are my two triangles. So I'm going to use those two triangles to set up my problem. We're trying to find the height of the flagpole. So that's what I'm going to label with X. Here's the flagpole. We'll label that with X. It's not already labeled for me. Are we dealing with sides of these triangles, or are we dealing with angles? Dealing with sides, or are we dealing with angles? The flagpole is representing a what? Side, right? So we're trying to find the side of this yellow triangle, which is the height of the flagpole. What are we going to set up to solve? Proportion. Fraction equaling a fraction. We're trying to find our flagpole, which we labeled with X. It's in the big yellow triangle. Which side corresponds to the flagpole in this green triangle? Is it the person or the ground? The person, right? How tall is the person? 5. So that's going to go on the bottom. Person's representing the flagpole in a little triangle. They're in the same spot. So then how do we have to set up our next fraction? We have to go back to the yellow triangle. What's the only other measurement we have in the yellow triangle? 48, the ground, right? Well, what's the ground in that green triangle? 12, so that has to go on the bottom. And then you just multiply. Again, it's no different than what we've been doing. We have the diagram. You just have to read through your paragraph to figure out what you're solving for. And then mark that in your diagram. So cross multiply x times 12 is, well, that's 5 times 48 is, what do we have to do with the 12? Good. And then what do we get? the height of that flagpole. Why does it say that it is an inch of a foot? That's silly. There's no number. I don't know why. Sounds probably on the internet. I don't know why they put that. Question. Yes.
For example 5, what was the answer?
For example 5, you should have gotten 11, I think. 11. Other questions? Yes. Yes, I think there are some people in front of